Welcome to Lab 5 Part 1, where we will program Cramer's rule. Here we have the definition of Cramer's rule. To start, we will import numpy as np. Then we will define our function as Cramer with the inputs of A, the matrix, and B, the vector. Then a colon. Then we will set a constant n equal to the length of A, which we will use later in our calculations. Before we can calculate xi, we must first get di, where di is the matrix formed by replacing the ith column in A with the vector B. So to do this, we will start by declaring di equal to a list comprehension with the elements numpy array of A for I in range of n. Before we move any further, let's take a look at what di looks like. Let's run that. Then we will set our A as our identity matrix, and B will be equal to a vector 1, 2, 3. Then let's go ahead and print out Cramer with inputs A and B. Here you can see di is a larger matrix containing our A matrices. Moving on, we must replace the ith column in A with the vector B. To do this, we will use a for loop for I in range of n. Then we will set di at I, where di at I is just one of our A matrices inside di. For that matrix di at I, we must replace the ith column with B. So here we will use another square bracket, colon, which means all of the rows, and then comma I, which is the ith column. And this will be equal to B. And our for loop will do this for all of the matrices in di. Now that we have di, we can calculate xi. So let's go ahead and return a list comprehension where the element is xi. Looking at the equation for xi, the numerator is the determinant of di. So we will use numpy.linalg.det of di indexed at I divided by the denominator, which is the determinant of A. So numpy.linalg.det of A. And then for I in range of n. Let's go ahead and run that. And here we have our solution. To make our matrix more readable, we can wrap our list comprehension in numpy.vstack, which will return a vertical stack. This function can be improved by first checking that the determinant of A is not equal to 0 before returning this line. You could do that by using an if-else statement. In the case that the determinant of A is 0, we would return an error message.